let's see if generative AI Claude 3.7 Sonnet can replicate my own paper. So I have my paper here to omit or to include integrating the frugal and prolific perspectives on controllable use with Fabian Mandel as the first author, and I'm the second author. And this is a fairly simple simulation paper, and it was started as a project by Fabian when he was a student on the course that I was running. So the course included a Monte Carlo simulation project as the final project, and this is based on an extension of Fabian's project. So what I'm going to do here is that I have this folder where I only have the PDF of my file. So this is it's available for Visual Studio Code. This is the Visual Studio Code editor. So this is a programmer's editor, and I'm using Klein Coding Assistant, and I'll be using this for various data visualization and data analysis tasks. And what I can do here is simply tell the agent what I want it to do. And I've already wrote the prompt here. So I'm telling the agent that it should replicate the simulation number 1, important controls, and reproduce figure 4 of this paper. And it should use R. And the paper also includes simulation 2 and simulation 3. I don't want to replicate those because that just adds to the cost of it. So I'm paying for each token that this client agent is using. So this is like you pay per use instead of paying a monthly fee. So what we're going to do here is that we are going to simulate data from a scenario where we have important controls. So the idea of an important control is that we have a control variable x, and the x might have an effect on y. So x is the focal variable, and we are interested in estimating this beta here. And then we have C1, the first control, and the C1 is important, which means that the correlation between C1 and y is 0. But C1 can be correlated with x. And for this correlation to be 0, this C1 actually must have an effect, because otherwise it would be correlated with y because of the correlation between x and then the path from x to y. So if you apply path analysis tracing rules, you see that because there's a path from C1 to x to y, then this path must be exactly the same, but the opposite direction for the correlation to be 0. This simulation also has multiple different control variables. So we simulated the number of control variables, and the simulation conditions are listed in the paper. And we're trying to reproduce this figure 4 here. So the figure 4 compares two strategies. One strategy is what we call the prolific, to use all controls that we have in the data. And the other one is frugal, which includes using as few controls as possible. And specifically in the frugal strategy, there's this rule of thumb that if a control variable is important, which means that it's not correlated with the dependent variable, it should not be included in the regression model. So this is not an appropriate rule, because the decision criteria should be that if you have a control, if that control is causally related to the dependent variable, then it must be control 4. And it's possible to have a causal effect, but no correlation, and that would be the case of suppression. So the rule is looking at an incorrect thing, so it's looking at the correlation instead of a causal effect. And we showed in this paper that this rule is not a useful rule. All right, let's get to the replication. So what I'm going to do is that I'm just giving the LLM, Claude. We have Claude 3.7 Sonnet here. It just has access to the PDF. So it can see the PDF, it can see all the files that I have here, and then I'll tell it to replicate it. And let's see what happens. So you can see how many tokens are used, and then here's the cost. For some reason, the cost is not updating yet. And I'm having this in planning mode first. So Claude read the paper, and now it's planning how to do the simulation. And then I can review the simulation plan. And after I've reviewed the plan or the replication plan, I can then decide if I want to have it act. So let's make this a bit wider so we can see what it wants to do. Yeah, so for some reason this is not updated. but this cost like maybe 10 cents this far based on the token use. So I've used, if you go into the millions of tokens, like a larger data visualization project, for example, then it's going to be a few euros, a few dollars, but this is still in the cents. And this shows the context window. So we have 200,000 tokens, and once you run out of the context window, then you have to stop doing it. So, but it's pretty good at using cache, which kind of rolls back the existing context window use. So let's see if it understood it correctly. So sample size is 250, and that seems, yeah, that's what we had. Then the number of controls is the same, yeah. And the correlation between X and C, there is a bit of a notational problem here, but it is between 0 and 0.8, so that's correct. And first control C was anchored with a dependent variable Y to produce an important control. And then we had R square of 30%. So let's see if that is the case. So it has been a while since I took a look at this paper. So yes, that is the case. And then we also explain that the controls were correlated with one another, and it doesn't really talk about that yet. So here's the plan. All experimental variables are variance of 1, and we probably need to tell it that they are also correlated. Importantly, the simulation data are available on OSF, but we didn't see this agent downloading anything from there. So if it wants to download something from the internet, it always asks for permission, and it didn't do so. So it's just reading this paper. And this is the correlation between the explanatory variables. So this is the correlation between x and the control. So that's correct. And prolific perspective always include control variables. Yeah. Include only things like correctly be dependent variable. Yeah, that's right. And then implementation plan in R. Generate data. Uncorrelate with Y. Okay. Create dependent variable. And it's kind of weird that it first wants to check that it is uncorrelated with Y and then generate the dependent variable Y. But let's see what it does. And we run multiple verifications models using both perspective or bias in the estimate, and then plot the bias against the correlation between X and C. Separate lines for different number of numbers. Okay. And then it tells that we want to have this bias. And then we click on act, and then it starts coding it for us. So it starts by creating a file, and you can see on the left-hand side is the file from the previous round. So it does like rounds of edits. And because this is a new file, it just shows the blank file here. And this is the R code that it writes. And let's see if we can get it to work without any prompting. I've tried this previously with Claude 3.7. And it didn't quite work. It produced a simulation, but I had to prompt it quite a lot to have it simulate the important control correctly. And then it wants to execute the command. And let's first review what it did. So we have seed for reproducibility. This is correct. This is correct. R square correct. Yeah, that looks good. Control count. Then there's generated data, and this is a very inefficient way of setting the controls between corresponding with the X and its control. and we had all the controls also correlate with one another. So this will produce an inadmissible correlation matrix for high correlations, because it will make the correlations be uncorrelated with one another. So let's see, it will give an error, and let's see if Claude can fix it. And then we have the X predictor, so the control variables. Then we have the beta, and for the first control, we set the beta to cancel out the indirect effect through X, and that would be true. So it's first it produces this empty vector of coefficients, so it's 0 and then number of controls, okay, and this is the correct equation for the impotent control. And then okay, we didn't think about that in writing the paper, so this is just the first control, and others are the coefficients of 0. I don't remember exactly what we did in the paper, so whether we had all the controls as impotent. We probably had the first control as impotent, and others just to have some kind of coefficients. Okay, and then this looks right. So that's like variance explained, and then you calculate the error variance based on the R squared. That is what I would do. And then this is just the regression coefficient, and then there's the fitted value. You can do this a lot more efficiently by just using a matrix multiplication, but it works as a loop. And then that's the error variance, it works. And then this is the data frame. This is quite a like verbose code. It works, but you could make it a lot more efficient, like less lines of code and less error prone. And then there is replication, okay. And then there is the prolific perspective, all controls. And then frugal perspective, only controls correlate with Y. And we use core test, okay, that works. And then only significant controls are included. And then only significant controls are included. And then both are returned. And then we have all the controls. And then we have replications. This is a bit inefficient. So using, instead of for loop, you should use a replicate function here. And then we have something that does the plot. So this looks good, except for this making the correlation here. So this will not work for large correlations between X and Z, because if you have a C1 that is highly correlated with X, and then C2 which is highly correlated with X, then C1 and C2 must also be correlated. And this keeps the correlations between the controls at 0. So I'm gonna run it and let's see what it does. Okay, so there's a programming error, and then the coding agent sees the error, and then it tries to fix it. And then it asks to run it again. And now it's running simulations. I'll speed up the video from here. Yeah, one of the things that Claude doesn't really see, or is that we are defining here that all the regression coefficients, if we have controls, they should have the same regression coefficient. And then it says in the code that for simplicity, it will just the first control important and other 0. So it doesn't exactly replicate what we want to do. And this is running way too slow for the video to be done in a reasonable time. So in practice, what we would do is to use multi-core processing to make this simulation run faster. And also, if we take a look at this, number of replications is 10,000. We don't need to have that. So what we can do here is that we can say that just for testing, let's run only 100 replications for each design. And then it'll kill the script, and then it'll fix it. Okay, and then we can run it. Let's see what it looks like. Yeah, this is the error that I said. So the correlations between the controls cannot be 0 because if C1 and C2 are highly correlated with X, then they must also be highly correlated. And let's see how it tries to fix it. And yeah, so it identifies the problem as this one, and then find the nearest positive definite matrix. That's one option, but the problem is that while that works, then it also might make the focal control bit to be not important. And okay, then there is some kind of warning messages, and it saved a file, and now it wants to see if the file was created, and then there's replication, and then it wants to open the file. And now we'll see if it got it correctly. So this is what it looks like. And so if we have the frugal and the prolific is the blue one, and the frugal is the red one, and there's be bias. It doesn't quite work, and of course, if there is no controls, and if there are 30 controls and then one of them is important, then it doesn't really make much of a difference if you drop one control from the paper. And we can also see that the prolific perspective is, and these frugal are, these 30 controls were not causally related to Y, and that is not what we had in the paper. So we had all the controls were important except for the all the controls are important, and that is kind of like an extreme scenario for the rule. So it kind of gets it right, but the problem is that the key information that is required for the replication is in a figure. So let's see if we can do a bit of prompting and tell the coding agent what it so how the simulations will be implemented. But it wants to print the bias, and then okay, so it reads the results from the CSV file that it produced. Both perspectives are very small bias, which is expected. Well, that's not what we say in the paper. Bias for the frugal perspective tends to increase, while prolific perspective maintains a smaller bias. Frugal perspective is a larger bias. That's completely different what we had in the paper. And this is consistent with what we would expect the paper's description in figure 4. The prolific perspective shows less bias than the frugal perspective. And the frugal perspective is a larger bias. So we have the bias is for the frugal perspective it's a small negative, and then prolific is well, there's no bias. there's like, if you look at these two controls, the prolific perspective indeed is a bit better. But it just works for the small number of controls. And if you have all the controls, let's take a look at that. Let's look at the results. Let's look at all the results and not just the first 20 conditions. Did the replication succeed? And it wants to create a plot that is using the first 20. Yeah. So it wants to do some kind of summary of the results. And now it thinks that it needs to edit the code. So I didn't quite understand that my first 20 was referring to this n equals 20. So we're gonna reject that, and then we're gonna restore to this checkpoint. So we're gonna restore to the part where it first ran it. We're gonna restore here. And we're gonna restore files and task. And then I'm gonna ask it to inspect the results in the CSV file. Look at the full file, not just the first n conditions. Does the replication reproduce the findings of the paper? And then it prints in the console and can read them from here. And we can see here that the frugal perspective here is more biased again, but here the prolific is more biased. Extreme large values which are not constant constitute what we express in big figure 4. In the paper, the bias values are much smaller, typically between 0.5 and 0.05. Correlation metrics are non-positive for higher correlation and higher number of controls, even though we tried to fix it. And then it wants to look at the first. We're gonna simulation results reject that, and what I want to do now is to tell it that there's a problem in how it was looking at the figure. So it was designed the simulation, and I will tell it that it designed the simulation correctly. Let's see, the simulation was designed. Let's say you design the simulation correctly, but the data code generation is incorrect. Take a look at the equations in figure 3 of the PDF. Can you see which controls were, how can you see how the betas were set for all controls and how the correlation and how the correlations between the C variables were set. So it wants to read the file again, and I have auto approve on for most things. So when you first start using Klein, it asks for approval for every task because you're accumulating costs. And this is now, it doesn't for some reason update the API cost here, but this is probably around €2 now based on the token count. Maybe less, maybe €1. And then also for data security, it's a good idea that you check any code that AI generates before it runs it, so that you don't accidentally end up deleting things on your computer. And also the same thing about sending files to the AI. You want to make sure that there's nothing confidential that you give it to AI. So let's see. So it was editing the file, and then so I see that I didn't correctly implement the data version 1. The correlation between x and each ci is correct c. The effect of x on y is beta 1. The effect of each ci on y is okay. So everything is important. That's not true. So let's see if we have. Let's ask if we can identify any equations in figure 3. Tell me all the equations you can see in figure 3 of the PDF. So this is the figure 3, and we want to see if we can actually read it. This is something that I dislike a bit myself in the paper. That if we zoom in here, so let's see if we can zoom. Let's zoom 400. You can see that this is bitmap graphics. So it's kind of like pixels instead of vectors. So we cannot just copy text here. So if this was text like vector graphics, then the AI could read it. But because it's bitmap, it's kind of like a photo, then the AI must use some kind of like image recognition to read it. And I'm not sure if you're gonna do it. So let's ask what it says. It's pretty good. In the paper, all correlations are each at the same length as they are with X. Okay, I also need control effects to be the same to cancel out their indirect effect through X. And let's see what it wanted to do. So if it read it correctly. So this is the Y equation, and it's kind of like takes it from this path diagram, I guess. And then we can see that beta 1 equals 1. That is not in the figure, but that's kind of like known from the text. And then beta 2 equals beta 1 times correlation xc. So that's correct. And beta correlation xc I for all controls have the same correlation with x. All controls have the correlation with each other as they with x. Okay, that's true. And let's see if we can see what is the correlation. What is the effect of let's prompt it again. Let's say look closer. Check what is the equation for beta 3 and how beta 2 is calculated when using multiple C's. So if this information was presented in the paper instead of a figure, this would probably be a lot easier. But at this point, I haven't given any information about the paper myself to the AI, so it's just reading the paper based on my prompting and my hints. I could just, and I'm gonna tell it how to set up the data soon if it doesn't figure it out itself. All right, so all other controls have zero effect. That's not right. All control effects to be the same. So beta 2, beta 3, beta 4, beta 5. That's not right. According to the paper, only the first control should have this effect and all the controls should have a zero effect. It doesn't say that in the paper, so it's hallucinating that problem. Let's ask, do you think this is correct? And all controls to be the same. That's not true. Let's just tell it what we need to have. So in the paper, the C2 is the important control. All other controls, if they exist, have the same effect as X. Let's switch to planning mode so it doesn't edit the paper, edit it now. And yeah, and I messed up. I meant to say C1 is important, others have effects and may be, and we do not care about whether they are important. Explain how you would generate. Let's see if it can figure out that this is not right, because it needs to take into account that there are spurious paths through the other controls as well. So when you have C1 that is important, when C1 is correlated with C2, then this direct defect must cancel out this indirect path as well. So we need to tell it that the important control is but if you were not an author of this paper, really knew this paper really well, it would be pretty clear that using seeing where the problem is, like where the AI is going wrong, would be quite difficult. When you use multiple controls, let's tell it that, did you consider also indirect effect of C1 through the other controls? So I'm giving it a hint where the problem is. Yeah, I need to read this to make sure that it's right. We didn't implement it this way because we implemented it generally. So we use this equation here, and just in case if we wanted to use different betas or different C's. With K controls, the indirect effect. Yeah, that looks good. And then let's run it and see what it does. Yeah, while this is running, you can think about it from this way. So this is, it doesn't not say the API cost here, but this is still like not not too much. So it's maybe few euros. I haven't gotten an email from Anthropic that I need to pay for more tokens, and I'm paid for 25 tokens. So whenever I or 25 euros. So whenever I run out of tokens, it bills me 25 euros more or $25 more. And I haven't received any emails, and I'll be using this all day for other things. So this is not that expensive. And if you never programmed a simulation, or even if you have, like writing this thing from scratch by hand, it probably takes a couple of hours. So even if the AI can't really fully automate it, this is a huge productivity gain. Let's see. So we're gonna run it. That looks very much like what we have in the paper. Let's have it to let's increase the replication count and make this a multi-core or parallel processing. And I'm gonna go to planning mode, so no editing of the code. And let's say that I want to use parallel programming. I want to use parallel computation processing. Use the future package, which is my favorite now for parallel programming. Use the future package. I have 10 cores available on the computer. Implement parallel processing on the replication level. Yeah, use future replicate. and then we are gonna move it to act mode. And now it wants to and this is the future replicate code. And this is something that's also useful. Like you can have your existing simulation code that you want to make multi-core compatible using parallel processing, and just tell the computer to make it parallel instead of doing it yourself. So I have an M1 Max computer, so it's a Mac, and there is 10 cores on this computer. If I run it without parallel programming, I'm only using 10% of the computational power of the computer. There's some kind of error. It's very hard to keep track of what it's doing because it's pretty fast, and it sees the error message in the console and it tries to fix it. Okay, it wants to use future apply, which it thinks it's more straightforward. I disagree, but whatever works. Then there's a nice Monte Carlo simulation package, and I want to port this code to that nice package. So let's intend remember the name of the package. Just called SimDesign. So I will port this to SimDesign next, which is kind of like automates some of this this plumbing, or this kind of like data management and looping and things. Okay, let's see. Didn't work. And at some point you can see that the program or the AI just sees that okay, it's not working properly, and because it can only run it at once, so it can't run it line by line as a human would be able to do. It might be better to just start debugging it myself and see what's the problem. But I haven't looked at the code for a while here, so I don't know what exactly is going on. So let's see if it works. And I should have said that it can use a smaller number of replications just to make the simulation run a bit faster when testing. So this is 1000. Okay, that's reasonable. It doesn't work. And now it's printing out the values here just to show what is going on so that you can debug. And if I was programming this using R, I would just use the debugger here and just set breakpoints, and then I would stop there and I could inspect what the values of all these are. But because the coding agent doesn't have access to the debugger, then it must just execute a code and print all kinds of output and try to infer what's the problem based on that output. let's see if it can fix that problem. It's really exciting to see how it works, and looks good. This is what we have in the paper, and we're gonna switch to planning mode, and we're gonna still do a bit of changing. So let's ask it to change the plot to look more like figure 4 in the paper. So the plot here is using facets. So it's splitting this into different panels, and the paper what we are using here is grouping. So we are grouping these instead of faceting, and let's see if we can get it to work. Original arranges the facets in a more compact layout. Well, we're not using faceting. The legend in origin is positioned at the bottom of the plot. Well, it's on the right-hand side, so you can see hallucinations going on. And so it doesn't really maybe understand it. So let's just say that the original figure 4 does not use faceting. It uses it changes, it uses colors to differentiate frugal and prolific. It uses line styles dash etc for differentiating, for marking controls. And what I want to do now is that instead of of saving, instead of rerunning the simulation, this is just the summary. I would prefer it to have the store the simulation, the raw replications on disk. Let's ask it further to port the simulation to use the SimDesign as package, save the raw replications to disk, save the results to disk. Actually, do that, but do not rerun the simulation. Instead, load the CSV file if it exists on disk. And the simulation should run if there are no stored results. Yeah, they are. The washing machine is on in the background. I wonder if it's going to be if it's possible to hear it in the video. Yeah, we don't want to install that. Let's see. Looks very similar to what we have in the paper. Of course, we had 10,000 replications, so all this messiness will go away when you increase the replication count. But overall, the pattern is pretty good. We could probably get this to the right-hand side, like what we have in the paper. And now the final thing. The legend was correct. Port this to this entire to use SimDesign package. It seems to know the package. This is a great package for doing Monte Carlo simulations. So I would always use this package if I study a new simulation from now on. And I wonder why it didn't use the package in the first place. And you can see that this starts to be a fairly big log now. So there are lots of tokens in the cache. And so it's getting a bit slow, but it'll do. Now it wants to run it. Let's review it first and see if it makes sense. And okay, so this is loading, and it loads things, and this design looks okay. Generate, that's the data generation. So sample size beta 1 r square, okay. That just looks good. And this looks good. This is unnecessary because it should be by design, but it's just kind of like left out from the, it's a leftover from the initial attempt, so it doesn't do anything, but this would be really bad to have in the code, because if you're simulating data and you're generating a non-positive definite correlation matrix, then that indicates that you have an error in your code, and it should not kind of like have this kind of workaround to deal with coding error. A coding error should cause the program to fail, and then it would fix it. And then there's the analyze. And it returns the betas. And then there's the summarize, which returns the bias. And this is the fixed objects, like looks good. and it runs in parallel processing. And let's delete the file simulation results just to make sure that it runs. So move to trash, and then we are gonna allow it to run that one. And okay, I don't have SimDesign installed because I updated R, and it just added it here. And now it's going to install it for me. So there's a difference between British and American English in this package. It's interesting to see what kind of errors the AI makes. So if I were to use this package, I probably wouldn't remember that there are packages written in using British English, and I would just say that thinking that it's analyze. So it's kind of like there's analyze, there is generate, and then there's summarize. And it's kind of like the AI might remember the concept, but not the exact term. So one nice thing about this package is that you can see this like how much memory is being used and what are the conditions. So it gives you a lot of this kind of like infrastructure that you might be useful for when you have your simulation. Yeah, it's a pity that it doesn't show the cost here because we are at several euros now, I think. But it's still cheaper than doing it myself. Yeah. This is one of the problems with using AI. If a human would be coding this, when you see that, for example, a line of code doesn't work, I'm just gonna let it run. So when you see that a line of code doesn't work, like this call to run simulation doesn't work, then you can read the documentation. And the AI really can't do that. So it's kind of like a human that has to rely on its memory without access to documentation. So it almost got it to work, and let's just cancel it. Let's fix it by hand. So I'm gonna take a look at the run simulation, the SimDesign package documentation, and let's move it here. So we have the run simulation command, and the design. Let's do just 10 replications to make it run a bit faster. So the run simulation here. There's design, that's write replications, write generate, write analyze, write summarize, write. Then there's fixed objects, which we have parallel true and of course true. We're just gonna run that debug. So let's do our debugger, and then we're gonna debug, and it's gonna stop there. So it's just 10 replications, so it's fairly fast. And the problem here is that we don't know the results. Let's see what the package documentation says, how this should be used. So we're gonna check the example of run simulation, and So it just returns a table, and we can just use it as it is. So let's go back to the code, and we can do results, print result. So that is what we have. And so it's directly a data frame. And is there even a function called SimExtract? Let's see. So there is, and let's read what it does. So you can get errors, warnings, seeds, and results if we had the full replication level results done. So it's kind of like trying to use the SimExtract function, even if that wouldn't be needed. And you can see here that it's just you can just see just like print the results. So it doesn't, you don't even need any of that stuff. So let's do results df. It's just gonna be results df, and we're gonna quit the debugger, and we're gonna just run it with 10 replications and then see what it does. Okay, so it doesn't work. I could go on debugging, but it doesn't make any sense to have people watch me debug it. The point here is that you can mostly replicate the simulation. Like we got a 95% working solution just by giving the AI the paper. And there are two problems with that. So this is a very useful tool, but if it doesn't work, then the AI might not be very good at troubleshooting why it doesn't work. Like we saw multiple times when it kind of got an error, and when the error would have been very easy to check by reading the documentation or fix by reading the documentation, the AI really can't do that. It just kind of like has to try various different things, kind of like a trial and error debugging. And it also doesn't have access to the R debugger, which you can just stop the R code and inspect what's going on. Instead, it has to print things and then read those printouts and then try to infer what the problem is. And number two is that the AI is pretty good at understanding the simulation design from just reading the paper, but it couldn't read the figure, which contained some of the formula that were needed to understand how the simulation is set up. And once I gave those formulas to the AI, it was able to execute, design the simulation and run it. If the AI does something incorrectly, it requires quite a lot of expertise to understand whether there's an error or not. So I wouldn't recommend that everyone goes and tries testing all kinds of ideas about methods using simulations with AI, even if they're not allowed to if they're not able to program it themselves. So unless you are not able to program this yourself, using these tools is somewhat dangerous because you can't fully trust the results. But for someone who has like basic understandings of how you use R or whatever programming language you would use, or statistical software. This works with Stata as well, but not as well as with R. And if you have some understanding of the technique that you're trying to test, then this tool gives you superpowers as far as doing simulations is concerned. So this is going to save me hours and days of time in the next paper that I write that uses simulations.